Hey everybody, this is Alex Merced from alexmercedcoder.com, and welcome to another episode of the Web Dev 101 podcast. In this episode, what I want to do is talk about two concepts. One, the difference between imperative and declarative programming. And two, the difference between, what's a graph database? And what makes it different than, let's say, a relational or a document database, and why it's pretty exciting once you kind of understand like why it's so different. So first, let's talk about imperative versus declarative. I think the best way to kind of understand this is to think about ordering like from a restaurant. So if I go to a restaurant, if I were to go to the waiter and order eggs imperatively, it would be like me going to the waiter saying, okay, tell the chef to take 2 eggs, break them open, put them in a pan, stir them around with some other fixins, some bacon and some broccoli and stuff. And then once it's nice and fluffy, take the result of that, put it on a plate, and bring it to me. That would be me ordering some scrambled eggs or an omelet imperatively. I'm giving all the specific directions. Like, I'm not saying what the end result is, nor does the waiter or the chef really know what the end result is. They just know they have these directions, and the thing at the end of the directions must be the result that I want. So if you ever use like jQuery or plain vanilla DOM manipulation, that is imperative. You are like, you can't say, hey, I want a navigation menu, and a navigation menu happens. You are saying a bunch of steps, saying, okay, create a div with this ID, add these children elements, append them to each other, then do some stuff in the CSS. And the result is what you wanted, but nowhere did you say, hey, I wanted a nav menu. The JavaScript doesn't know what a nav menu is, it just knows that it can append stuff to the DOM. Now, ordering declaratively, if I were to go back and order those eggs declaratively, if I said, hey, I want a broccoli, bacon, and cheese omelet, and then they went to the waiter, and the waiter brought me back a bacon, cheese, and broccoli omelet, that's declarative. I'm ordering declaratively. I didn't explain how to make what I wanted. I said, this is what I wanted, and they made sure that happened. Now, the only reason that's able to be possible is because the chef has some idea how to create the thing that I asked for. Okay, so there has to be like a recipe. And that's what you're doing with React. With React, you're doing declarative programming. So notice when you're like in your app component, you can say, I want this component, I want that component. So if you made a component called navigation, you can just say, put the navigation here. And the navigation happens there. Okay, so that's the declarative aspect of it. Once you create all these components, all you have to do is worry about creating the components by themselves, and then you can just declare where they are. Instead of having to create every time you want to use that component, having to create all the individual steps to make it happen. Now, of course, there has to be a recipe, so that's when you actually write the component, but even writing the component, there's still a lot of declarative aspect to it, because that's what JSX is bringing to the table. So in React, you use JSX, where you kind of write HTML in your JavaScript. So in this case, you don't have to write all the individual steps of, okay, create this element with these children element, append these elements to here, append that element there. All that's been abstracted away from you. All the imperative stuff has been taken away from you and abstracted to give you sort of this declarative method of doing the same thing. That's what React, Angular, and Vue provide for you. A way to declaratively create UI instead of imperatively creating UI. Instead of having to say every step of making the eggs, I can just say these are the eggs that I want, and that's the eggs that I get. So I can say, hey, I want a UI with the navigation component first, then the main content component, and then a footer component, and then that's what I get. Okay, and if I describe that any of those details change, aka state, then it just gets me rebuilds the thing that I asked for with the changed variables. And that's declarative programming. And so you'll see like most raw languages are imperative because they don't want to assume anything about what you're doing. They don't know what anything is. The raw language is just a way of giving directions. But people through libraries and frameworks can create more declarative styles of programming on top of it. Like the only language I can think of that is declarative from the onset is Elm. Like Elm was literally created for one purpose. It's a programming language built for one reason, to build UI Kind of like React is built in JavaScript to build UI, except Elm is literally a full-blown programming language specifically just for that, and has a very React-y type syntax, and it's very declarative because it's made for that specific thing. I'm not sure if this is the exact term I want to use, but we'll say domain-specific language is specific to a specific area, a specific thing. It's not a general-purpose language like JavaScript, Python, Ruby, etc., where basically you can do lots of things. So you can't really create a declarative approach out of the box into the language because we don't know what you're doing with the language. But people can create frameworks on top of the language for different applications that is declarative because they know what the recipes are for that. Same thing with like a lot of, when you think about using something like Express. Okay, Express can be very declarative as well, in the sense that I want a route that does X. I want a route that does Y. I don't have to sit there and create all this logic for how the server creates the requests and whatnot. It's a little bit not quite as declarative, I would say, as React. I wouldn't necessarily call like Express a declarative web framework, or any web framework for the most part. Rails can be kind of declarative, I guess, but that's the concept. Okay, the idea is like, am I describing all the steps, and I get the end result because you followed all the steps, or am I saying I want this, and you come bring it to me? Okay, so that's the difference between the declarative and imperative. Cool. So now that we got that out of the way, let's talk about graph databases. And really, like, what kind of database do you need? I would think about it this way. If there are 0 relationships in your data, so you don't care about tracking relationships, you're not going to really be pulling up like complex queries. You just like need to pull up like this bunch of data here and kind of ad hoc. Then a document database is going to be your best bet. Okay, it's going to be able to store the information more compactly because it's just really raw text. Okay, and the raw text is really just like saved as like JSON strings in like a database like Mongo or DynamoDB or Firebase store. They literally just store strings of text. There's no built-in sort of relationship mechanism. Like if you did want to do relationships in a document database like those, it would all have to happen. Those would all occur in your code. There'd be no sort of built-in mechanism for it. So basically, you would have to like sit there and say, okay, I want to query this document from a collection, and then that document would have maybe an ID for another document in another collection. Then I'd have to go separately query for that one, then separately query for the next one until I got all the data I needed. So the more related your data becomes, the less of the benefit of having a document database there is. Now, if your relationships are straightforward, okay, so if we're talking about like, most of your data, they're mostly a direct relationship. So like many-to-many, a one-to-one. You're not doing any really complex queries. So it's really just like, okay, I want to find all the dogs that Bob owns. Okay, so it's a direct relationship between a person and a dog. Then a relational database works really well, where it saves the data as tables. So unlike a document database, which just saves them as like basically text that has no uniform schema, meaning a schema just meaning like, okay, what kind of properties does this data have? So like, let's say every dog has an age and a name. It doesn't matter. Like in a document database, one dog could have a name and age and dog tags, another dog can just have name, and you don't know what the age is. It doesn't matter. There's no sort of prescribed schema for the data. Now you may be thinking, well, I've used Mongoose, and there I had to create schemas. Well, Mongoose is enforcing the schema for you. It's not the Mongo database that's doing it. Again, the document database is real straightforward. It just parses the text, fetches you the data you asked for, and adds to it. It's pretty simple. Thus, it's very scalable, very fast. A relational database like SQL databases, Postgres, MySQL, MariaDB, etc., what they do is they save in tables. So there has to be basically you have fields. Okay, so let's say every dog has a name and an age. Those would be the fields, so those would be the columns of the table, and each dog would be a row of the table. But there's always every row has the same number of columns. So if I don't know the age of the dog, there's still a spot for the age information for that dog. It's just blank. So I'm still taking up necessarily that space data wise. So you have a lot of incomplete data. You are essentially like saving a bunch of empty strings and uh, null numbers and whatnot. You're saving values. But the cool thing is, because there's a much more strict enforcement of like schemas, you can have relationships, usually via a foreign key. So if I want to say, okay, I have two tables, a list of people and a list of dogs. Okay, and every dog is owned by a person. Well, in the dog table, there could be a field called person ID that has the ID of the person from the person table who owns that dog. This is referred to as the foreign key. It's the ID of the thing they're related to. So in that situation, one person can own many dogs, but every dog is owned by one person. Also referred to as a one-to-many relationship. Now, that's all fine and good, but let's imagine this. Let's imagine, I guess the example you always see, and pretty much in every graph database example I've seen, they always use this. It's actually it's a good one. It works. Sorry for any sirens in the background. I live in Brooklyn. But imagine this. I want a list of all the actors that have co-starred with Brad Pitt in a movie directed by Quentin Tarantino. So how would that happen in a document database? Well, first I would have to like query all the movies done by Brad Pitt. Then I'd have to take all those movies and then query all the ones that were directed by Tarantino, and then I'd have to query all the actors in each of those movies. So there's like 3 steps. Okay, I'm in SQL. First, I'd probably be able to like get all the movies that Brad Pitt's been in, and then maybe be able to filter them by whether they were directed by Quentin Tarantino. I might be able to just do that in sort of one query. But then I'd have to separately then go query each of those movies for all their actors. Okay, so again, the query gets more complex. There's more operations running. But in a graph database, I could just do that in one query. I could just literally just say, hey, get me all actors who have acted in a movie directed by Quentin Tarantino, and then basically say, movies that have Quentin Tarantino as a director and Brad Pitt as an actor. And then I got it. Because the reason is that the way a graph database organizes the data is not just as like a bunch of plain text objects. It's not tables and rows. Okay, you're not talking about columns and rows. It just saves each piece of information as what's called a node. And it's kind of like what you see in a document database. Each kind of piece of information, each document is kind of freestanding, but again, it's not tracking the relationships between each other. Instead, here, each node in a graph database can have a pointer to any other node, and every node can have a label. So instead of having tables, you just have labels. So every actor might have a label of actor. Every movie might have a label of movie. Every director might have a label of director. And I think you can have multiple labels. So I could say, hey, Brad Pitt is an actor director. So he has multiple labels. So that way I'm not having to create like 2 separate nodes, Brad Pitt as director, Brad Pitt as actor. So one, that gives you sort of like more reusability of the same data set. Like I can create Brad Pitt and he can have different roles. And then 2, instead of saying, okay, I have Brad Pitt and he's been in these movies, you create what's called an edge. So every node, sometimes also referred to as a vertice, a vertice, or vertices, plural. Okay, but one node, one vertice, has an edge or a relationship to another node. Okay, and they could be other nodes at the same type. They can be multiple nodes. It doesn't matter. So basically what would happen is that let's say there's 5 movies that I know Brad Pitt's been in. I would just draw one, and then they all have a label of movie. They're all just separate floating nodes. I would just say, hey, Brad Pitt was an actor. I would just draw this edge, this line that connects it, say Brad Pitt was in this movie, and I'll label that relationship as acted in. I can call it whatever I want. long as I keep it consistent. So then I just keep doing that. Acted in this movie, acted in this movie, acted in this movie, acted in this movie, and then I can say, hey, Quentin Tarantino, draw edges and say, hey, directed these movies, and then I can again do those queries. But the way it does it, it doesn't have to look like when you're in a document database, it just kind of goes through all the documents until it finds matches. And depending on your query, that could be pretty inefficient if you're talking about a large amount of data and you're talking about multiple queries. Again, no relationships, your document database is still probably going to be your best bet. Simple relationships, SQL is going to probably be your best bet. But if you have crazy complex relationships, think about a social network. A graph is going to be awesome, because imagine like all the kinds of weird interactions you have on Facebook. Okay, think about a like button. How do we keep track of everything that you liked? Okay, that would be really complicated, because then I'd have to sit there and like, okay, if you ever try to do a like button in an SQL database, it's quite painful, because you have to like create like a list of like, okay, you have to create like a join table, say, okay, with every combination saying, okay, this person liked this item, this person liked this item, this person liked this item, and then you'd have to query that database to get all the aggregate likes for that item, and that can be very expensive transaction-wise over time, because you still have to like, the database has to look through each row and see which ones match. But since in a graph database, they all have direct touches to each other, so basically that node actually, when you draw that edge, it's actually pointing specifically to the node that it's connected to. So I can just say, get me all the items that liked this thing, and it doesn't have to look through every like ever. It just has to, it just follows those little edges. It just follows those lines and finds the likes that are directly liked. So it's going to be faster, but again, more flexible. Unfortunately, they're not, graph databases aren't as ubiquitous as like, so like right now you can easily get like a free document database with like MongoDB or Firestore. I'm not sure if you can get DynamoDB really for free. You could, I think, for like the first year with like Amazon. You can get a free Postgres database from Heroku, and you can get a free SQL database from Google with like, it's like Fire, I forget, it's like Fire RDB or something like that. And then Amazon has their relational database. Okay, so you can get those pretty easily. Those are databases you can get up and running pretty quick, or MySQL or whatnot. Not a hard thing to get. A graph database is a little bit less ubiquitous. Like I was looking for like a free graph database. The only one I'm aware of is dgraph. Like there used to be more options, but it looks like a lot of them have shifted their business models. But dgraph, which was recently featured on the Fireship YouTube channel, great YouTube channel, basically is a graph database that actually has GraphQL built in. So the way you actually query that database is through GraphQL, which is actually really cool, because GraphQL, the whole point of GraphQL is to make querying making APIs more declarative, and that's goes back to the whole declarative versus imperative thing. Like GraphQL, instead of just saying, hey, get me what this URL gets me, and then that URL just gets you some data, you actually saying, okay, I want this data, and I only want this pieces of information of this data, give it back to me. And that's built in natively into dgraph, which I imagine would make it more performative. Because right now, when you usually make a GraphQL API, you're making it on top of like a document or an SQL database. So you're not necessarily making the SQL or document database more efficient, but you are making necessarily your API calls more efficient and the amount of data they're taking. But here you can kind of like make the whole chain more efficient, which is really cool. So that's called dgraph. The other really big one is a Neo4j. And I'll probably be coming out some videos on Neo4js. I've been playing around with it for the last like 48 hours. There's a service called Aura that's going to be coming out with like, and they exist already to have a paid Neo4j server. But they are going to be coming up with an Aura free, which like gives you like free developer servers, so that way you can learn how to use Neo4j in your hobby projects and get and see if it's like the database for you. And there's other graph databases. Those are the two that I know off the top of my head. And some are built on top of other databases where they, basically they're providing sort of the graph structure on top of other existing databases. So maybe on top of a document database where you're saving all the data in a document database, but this whole like logic of nodes and nodes pointing to each other and all that stuff is handled by like an overlay of a graph overlay kind of thing. Well, since I'm talking about different types of databases, I'll just talk about a couple other ones. Um, there is sort of like a basic key store. That's kind of like what you've used with like local storage and session storage in your browser, where basically there really isn't tables of data. There's just a key and data stored based on that key. So you just query, say, hey, give me this key, and it gives you the data back. So for very simple like one-off pieces of data or small JSON strings or XML strings, really doesn't matter. I mean, it's just strings hidden behind a key. Those are pretty cool. Okay, so that's like Keystore databases. Like there's memory cache databases like Redis, where they're databases that also kind of key value stores. The difference is that they're storing the data in memory, meaning theoretically the server restarts, that data is gone. But generally they're not meant to be sort of the permanent store of your data. So the idea is like, okay, your SQL and document databases are where you store your data permanently, but it is a little bit more expensive and it takes a little bit longer to be querying them over and over again. So if there's certain queries that you know are going to repeat themselves quite a bit or not going to change very often, you can use something like Redis to cache the results in memory, in your server's memory, so that way if someone asks for that again, it's just already ready to go. And maybe like expires once a day, and we'll do a fresh query like a day later. This way, you know, you're making more efficient use of your database and providing a faster fetching of data. And then there's like Elasticsearch, which I don't understand Elasticsearch right now, so I'm not going to explain you exactly what that one does. But that's like what's used for like search engines and such. But yeah, graph databases have become my new sort of like the thing I'm interested in right now. So that's why I wanted to do this episode. And I finally felt like I could explain the difference between imperative, declarative clearly. So I wanted to get that out of the way too. So hopefully you guys enjoyed this episode. Make sure to head over to alexmercedcoder.com, subscribe to my YouTube channel, subscribe to this podcast, tell your friends, head over to devnursery.com and join the Slack and Discord community. And yeah, have a great day and enjoy. I'll see you guys next time.